So in this video, we're going to talk about the law of cosines. So what is the law of cosines? So law of cosines is used to solve problems involving triangle, specifically not right triangle, because if it's a right triangle, then you just use the SOHCAHTOA in solving it's a known variable or angle. But in this case, those triangles which cannot be solved by law of sines, we use the law of cosines. So what is the law of cosines saying? So it says that let's say the side A is square of side A is equal to the sum of the square of the other sides, which is b squared plus c squared, minus 2 times the two sides b and c times the cosine of the angle opposite to A, which is the capital letter A. So the same thing if we use the other side, B and C. So if it's B squared, so it's going to be equal to A squared plus C squared minus 2AC times cosine of the opposite of the B, which is the angle capital letter B. And if we use C as a reference, C squared is equal to A squared plus B squared minus 2ab times cosine of the angle C. Now let me show you an example of a triangle where you can apply the law of cosines in solving its unknown variable. So in this case we have the angle, this is what you call the included angle, 75 degrees. So we call that included angle when it is in between the two sides involved in the problem. Either the two sides are unknown or the given sides. So it's called included angle. So opposite to the included angle is the unknown variable x, and that's what we are looking for. So let us use the law of cosine to solve the value of x. So we can write x squared is equal to the two sides. So we have 15 squared plus 20 squared minus 2 times 15 times 20. So you might ask, where do we get 20? Where do we get 2? 2 is all it's constant, it's fixed. So it's already part of the computation of the law of cosine. I mean the formula. So times cosine of the included angle 75 degrees. Now let us compute each term. So let's copy first x squared equals, then 15 squared, or 15 times 15 is 225, plus 20 squared is 400, and then minus 2 times 15 times 20 times cosine of 75 degrees is approximately 155.29. So if anything involved an angle, make sure that your calculator is in degree mode, not in radian. So we combine these three terms. So let's copy first x squared and equals, then combine the 225 plus 400 plus minus 155.29. So it will be 469.71. So next step is we are after of x, so we need to remove the square on top of x. So we're going to take the square root of both sides to cancel the square of on top of x. So what's left is only x, and take the square root of 469.71, so it's approximately equal to 21.67, and then put the unit inches because the unit in the given is inches. Now let's take, for example, this triangle is having all sides given, but we have an unknown angle denoted by the Greek letter theta. So to find the theta, we use this formula. So by the way, the pair or the paired side and angle, or the included angle, is this 12 and the theta. So we use this formula to find the angle when using the law of cosine. So it's cosine theta equals b squared plus c squared. So by the way, the b and c are the two sides at the side of the included angle, minus the a squared. So a is the side opposite to the angle theta, which is the 12 feet in our given, over 2 times b times c. So let's substitute everything. So we have cosine theta is equal to 16 squared plus 8 squared. Those are the two sides at the side of an included angle. Those two are interchangeable. Minus 12 squared all over 2 times 16 times 8. So you might wonder where we get this formula. This formula is just actually from the original equation that we have a while ago, but we just derive it such that we only have cosine theta at the left side. So let's compute each term. So copy cosine theta equals, so 16 squared is 256, 8 squared is 64, and 12 squared is 144. Over 2 times 16 times 8 is 256. Then combine the top. So 256 plus 64 minus 144 is 176. Now you may not divide yet the 176 and 256. So what we do is to transfer the cosine to the other side, because what we are after is only the theta. So what's left on the left side is theta. And where's the cosine? So it is transferred from left to right, but you have to take the inverse of it if you are transferring a trigonometric function like cosine function. So, and then put inside the parentheses the 176 divided by 256. Then calculate the inverse cosine of the ratio. So it's approximately 46.57 degrees. As I said, your calculator should be in degree mode, or else even if it's correct process, it will give you an incorrect value. Now another example of a triangle with a known variable. So we have x 5 yards and 12 yards are as the sides of a triangle, and the included angle is 70 degrees. So it's a little different with the first example because the paired side 12 yards and its opposite angle, which is 70 degrees, are both given. So now the unknown variable is actually part of those sides at the side of the included angle. So how do we compute this? So let us set it up with the equation for the law of cosine first. So we have 12 squared, which is the opposite of the included angle, equals x squared plus 5 squared minus 2x times 5 times cosine 70. So let's compute first each value by term. So 12 squared, or 12 times 12 is 144. Then we'll just copy the x squared. 5 squared is 25, and then 2 times 5 times cosine of 70 degrees is 3.42, and then copy the x. So to solve for x, observe that in one equation there are two values of x. There are two x variables. So the first thing to do is to transfer first this 144 to the other side to make the left side 0. By doing this, subtracting 144 to both sides to cancel this, so it becomes 0 the left side, equals x squared, and then combine 25 and negative 144, so it will be negative 119, and then copy the negative 3.42x, or the minus 3.42x. Now next thing to do is just to rearrange it such that the x variable is arranged according to its exponent. So we have x squared minus 3.42x and minus 119. So the reason is to solve this using the quadratic formula. So using the quadratic formula, we can able to identify the value of x even if there are two x's here in the equation. It's because it is forming a quadratic equation. So what is a, b, and c in this equation? So at the side of x squared is the a, at the side of x is the b, and at the side of, the constant is c. So substitute these values in our quadratic formula. So it will be like this. We have um, a is 1, b is negative 3.42, and c is negative 119. And then if you calculate this, you will have two values. X is approximately 12.75, and it's also approximately negative 9.33. But we don't take this as part of the solution because x cannot be a negative because it's a length of side, so it's impossible for us to have a negative length. So the answer is x is approximately equal to 12.75 yards.